Let's do a problem from your lab assignment, section 11.5. This is number 2. They want us to test a series for convergence and divergence. If the series does converge, use the alternating series estimation theorem to determine how many terms we need to add in order to sum up the errors less than 0.0001. So the estimation theorem tells us that the remainder, r sub n, is going to be s minus s sub n, is going to be the b sub n plus first term. And so if we want to look at the b sub n plus first term with the actual value of error that we want. Okay, so notice this is very similar to the alternating series test, where you have to make sure that it actually does converge and satisfies these things. All right, let's go back to our problem. And our series is a series that goes from 1 to infinity of -1 to the n divided by n times 10 to the n. So we have a 10 to the n in the denominator. This is has a very good chance of converging. And in fact, even if we take the absolute value of this, our denominators are going to get larger and larger, and so that's going to be decreasing. And furthermore, if we take the limit as n goes off to infinity, we'll have a number 1 divided by infinity, and this is infinity times 10 to the infinity, so that's infinity. And so that's going to approach 0, and that would satisfy our alternating series test convergence. And it looks like not only is it going to converge in the alternating series, but if we take the absolute value, it looks like it'll converge that way too. So anyways, now we want to find the remainder. Has to satisfy r sub n is less than or equal to b sub n plus 1. And b sub n is n times 10 to the n, so b sub n plus 1 is going to be n plus 1 times 10 to the n plus first power. So we want to make n large enough so that this expression, the b sub n plus 1 expression, is going to be less than 0.0001. So it's basically plugging in some values. They suggest we plug in b sub n plus 1. So with b sub 2, this is going to be 1 plus 1. So we're going to put n is equal to 1 in here. And then we're going to try with n is equal to 2, and etc. So the best way I found to do that was to use Excel. And here's our Excel. So let's say we have some n values, and then we have 1 divided by n times 10 raised to the nth power. And so we're going to put in the values 1, 2, 3, 4, 5, 6, etc. And then we're going to take our expression and say equals 1 divided by, and I'm going to put our parentheses around our denominator. We have the n value that we have times, and then we have 10 raised to the same n value that we have. So when n is equal to 1, we have 0.1, but we want starting at 2. So I think here we get 0.005, and here for the next one, b sub 3 is going to be 0.000333, and then the last one is 0.4. When n is equal to 4 is 0.000025. So we want 0001, so this is 0003, and this is 00002. So our convergence to within 0.0001 is going to be between B3 and B4. So so B sub 3 and B sub 4 I think b sub 4 would be the safest, and this happens when n is equal to 3. And remember, this is n plus 1, so b sub 4 is a term to be less than 0.001, and so we need to add the first 3 terms to get the desired accuracy, because the fourth term then would be what they were looking for. All right, I hope that helps.